All right, today we're going to look at systems with three variables. Now, the steps that are off to the side, I'm going to change them a little bit. I don't like them very much. I think it gets a little bit complicated just because sometimes the order isn't so nice. So I'll kind of tell you what to manipulate on these steps. What we've done so far is solving systems with two variables using substitution, elimination, or graphing. With three variables, we are going to be doing a combination of elimination and substitution. And so it's really important that you understand about your zero pairs. That's going to help us go from three variables to two variables, and then from there it becomes a lot easier. So what we're going to be doing is looking at the three equations. The first thing I want you to do is I want you to label them 1, 2, and 3. And I usually do, I circle them. I go 1, 2, and 3. Because we're going to choose, like it says in step 1, two equations in which you can easily eliminate a variable, whether you can automatically see a zero pair, or maybe we have to multiply one of the equations by a number to be able to get that zero pair. But like it says, let's call this new equation after the elimination equation A. I'm not going to do that. I usually just call that equation 4, since I'm labeling 1, 2, 3, 4. Step number 2, we need to pick two different equations and eliminate the same variable. So we're going to eliminate that same variable from a combination of the equation that you didn't use. So we used 1 and 2 first time around. Then I would have to use 1 and 3 or 2 and 3 the second time around. We're going to call this equation 5. So we're going to put equation 4 and equation 5 together, and then we're going to solve that system of equations using either substitution or elimination. Usually it's going to be elimination, but you do have those two options. Then you substitute your answers from step 3 into either original equation to find the remaining variable. We're going to be writing our solution as, instead of an ordered pair, it's an ordered triple. There's 3 values. There's an X, a Y, and a Z. And again, it goes in alphabetical order. So it's really important that you learn how to organize your work. If you start putting things all over the place, you're going to get very confused. So looking here at equations 1, 2, and 3, we have 2x minus 6y plus 9z equals negative 8. 5x plus y plus 2z equals 10. And then I see 3x plus y minus 8z equals negative 28. So looking right away, step number 1, choosing two equations which we can easily eliminate. Looking at it right now, I can see that I have no zero pairs. However, when I look at the y's here, I can see that one of them is a negative and 2 of them are positive. So I know that it'd be easy to just multiply one of them by a number. So if I pick my y's to get eliminated, if I pick equations 1 and 2, 2x minus 6y plus 9z equals negative 8, and equation 2, but I want to eliminate the y. So in order to get a zero pair with these two, I need a 6 in front of that y. So I'm just going to multiply this whole equation by 6. So I'm going to multiply this whole equation by 6 to get my equation 2. So remember, we're multiplying everything by 6. So this becomes 30x plus 6y plus 12z equals 60. And now I'm going to add those together, just like we did with elimination. And I can see my zero pair right here, so those are going to cancel out. So I'm left with 32x plus 21z equals 52. All right, can't do anything else of that. I can't solve for x or for z because I have two variables. So now we go to step 2. We're going to eliminate the same variable, but we're going to use two different equations. So I used 1 and 2. Well, 2 and 3 are very similar in the sense that they both have these y's here. So I can use 1 and 3 to also eliminate that y variable. So here, what I'm going to do is I'm going to use equation 1, 2x minus 6y plus 9z equals negative 8. And then I'm going to multiply my third equation, again, by 6. And I'll write that over here. So this one's going to be 18x plus 6y minus 48z is equal to negative 168. All right, I'm going to add those together, and again, we always want to eliminate the same variable, and the reason is we want two equations that have the same variables. So we have 20x minus 39z is equal to negative 176. So remember before, so when we eliminate the first one, our answer, we're going to call this equation 4, and we're going to call this equation 5, and we're going to put these two together. So I'm going to put those together over here. And we have 32x plus 21z is equal to 52. And 5 is 20x minus 39z is equal to negative 176. So just looking at those two, I can tell, I can't see a zero pair right away. These numbers are really big. But I can see that if I look for my multiples, eventually I get to, let's say I want to eliminate my x's. My least common multiple is going to be 160. So if I want to eliminate my x's, my LCM is 160. So that means I need to multiply this whole thing by 5, and then I'm going to multiply this one by a negative 8. And that's going to give me a zero pair with a 160 in front. So when we write those, we get 160x plus 105z is equal to 260. And then we get negative 160x plus 312z is equal to 1408. And now when I add those together, we have our zero pair here, cancels out, and we're left with 417z is equal to 1,668. And when we divide both sides by 417, we get z equals 4. So we have one of the three values for our solution. So now that we have that z, we're going to use either equation 4 or 5, it doesn't matter, and we're going to plug in that z to get the x. So let's look at, we'll use equation 4. We know that z is equal to 4, so we're going to do 32x plus 21 times 4 is equal to 52. We get 32x plus 84 is equal to 52. Subtract the 84 to the other side. 32x equals negative 32. Divide both sides by 32. We get x equals negative 1. So notice that we have really large numbers, but when we're solving, we're getting nice small numbers. Just because we have large numbers doesn't mean that we're always going to have large numbers for our solution. Well, I have my x and my z, so now I'm going to pick between equations 1, 2, and 3 to solve for y. I'll go ahead and use equation 2. x equals -1, z equals 4. So I'm going to plug that into equation 2. We have 5 times -1 plus y plus 2 times 4 is equal to 10. So -5 plus y plus 8 equal to 10. So if we move that 8 over, we subtract it over to the other side, add 5 to the other side, we get y is equal to, let me write this down, 7. So our solution our x's go first, -1, then my y's, 7, and then my z, 4. So again, it's a combination of elimination and substitution to help us get our solution. Let's go ahead and try one more. So again, we have 4x plus y minus 3z equals 45, 6x minus 4y plus 3z equals 41, and then 2x minus 7y minus 11z equals to 85. So looking here, first thing I'm going to do is I'm going to label these 1, 2, and 3, just so I know to separate my equations. And there's a few things we can do here. I can see my z right away that I can eliminate. I don't have to multiply by anything. If you wanted to eliminate the y's, you could. We can see we have, we would have to multiply an equation to be able to cancel. We can also eliminate our x's, but again, we'd have to multiply to cancel. So it just depends on what you prefer to do. I'm going to go ahead and do my z's just because I have a 0 pair right away. So I'm going to use equations 1 and 2. We have 4x plus y minus 3z is equal to 45. And then 6x minus 4y plus 3z equals 41. So here I see my 0 pair. So this leaves me with 10x minus 3y equals 86. So remember, this is equation 4 that we've created. And then now looking, since I used 1 and 2, I cannot use 1 and 2 again. But I want a positive and a negative, so I'm going to use 2 and 3 just because one's positive and one's negative. I don't need to worry about multiplying by a negative to get the one positive and one negative. So I'm going to use 2 and 3. Again, it doesn't matter. You could use 1 and 3 if you wanted to as well. But I'm going to use 2 and 3. So looking at eliminating z again, my least common multiple between 3 and 11 is going to be 33. So I need to multiply my 3 by 11 and my 11 by 3. So I'm going to multiply equation 2 by 11 and equation 3 by 3. So I'm going to move that over here on the side, and that gives me 66 minus 44y plus 33y equals 451. So I multiplied equation 2 by 11. Equation 3, I multiply by 3, we get, oops, I forgot the x here. 6x minus 21y minus 33, this should be a z. Made some mistakes. So this is 33z. There we go, x by z. Fix my mistake. So 33z is equal to 255. 85 times 3. All right, so now we're going to combine those together. I have my 0 pair with my z's again, so I'm left with 72x minus 65y is equal to 706, and that's equation 5. So I've done my step 1 and 2. I have eliminated the same variable, in this case the z's, and now I have 2 new equations. I'm going to write those down over here. So 4 is 10x minus 3y equals to 86, and equation 5 is 72x minus 65y equal to 706. So looking here, what do we want to get rid of? Again, it doesn't matter, whatever we want to do. Let's go ahead and get rid of the x's. So between 10 and 72, the least common multiple, I believe is 360. And I'll show you in class how to get your least common multiple using your calculator. So what we're going to do here, we're going to multiply this whole equation by 36. And we're going to multiply this whole equation by -5. And that's going to give me my 0 pair for my x's. So 36 times 10x is 360x. 36 times -3y is -108y. 36 times 86 is 3096. -5 times 72x is a -360x. -65y times -5 is a positive 325y. And 706 times -5 is a -3,530. So here we have our 0 pair. We're going to add these together. Here's our 0 pair. We get -108 plus 325 gives me 217y. And 30,096 minus 3,530 gives me a -434. So when I divide both sides by 217, I get y equals -2. Once we get that first variable, it's substitution, and it's really simple. Now we're going to pick either equation 4 or 5 to plug into. Again, it doesn't matter. We're going to get the same answer in the end. I'm going to use 4 just because it's smaller, and we're going to plug that into equation 4. So we have 10x minus 3 times -2 equal to 86. We have 10x plus 6 equals 86. Subtract 6 to both sides, we get 10x equals 80, so x equals 8. Now that I have my x and my y, we have to go through equations 1, 2, and 3 to pick for the z value. And again, it does not matter which one we choose. I'll go ahead and choose number 1. So we have an x equal to 8. We have a y equal to -2, so I'm going to plug everything in. 4 times 8 minus a -2 minus 3z equals 45. Please don't forget to use parentheses. Make sure that you don't make careless mistakes. So we have 32 plus 2 minus 3z equals 45. So we have 32 plus 2 is 34. So we're going to subtract 34 to both sides. We get -3z is equal to 11. Oh, I think my math is there wrong. -2. Oh, this should be a plus, not a minus. It's a plus here. So this is a -2. So this is 30. So we're going to subtract 30 to both sides. So 45 minus 30 gives me 15. There we go. See if I can make that a little prettier for you. Make this a little bit smaller. There we go. So this should have been a -2, which should be subtracting 30 to both sides. There we go. So my z is equal to -5. And we divide both sides by -3. So our solution again, we put this in order, x, y, z. So my x is 8, my y is -2, and my z is -5.